Okay, hopefully you've done this with larger and larger numbers of compoundings. So here's the expression for 1,000,000 compoundings. If you compound 1,000,000 times, then you take your 100% and you divide it by 1,000,000. In decimal form, that's going to give you, well, 1 over a million, 0.000001, raised to the 1,000,000th power. And I asked people to do that, and they got 2.7182804. Okay, well, we don't any longer have the result from the last video, but maybe you wrote it down, or maybe you want to go back and take another look at it. But it agreed with this up to a point, but this one starts to diverge from that one around the 4th or 5th significant figure. Okay, we could go past 1,000,000. We go to 2,000,000, wouldn't change that much. We could go to 10,000,000 or 100,000,000 or a billion or a trillion. There's a limit, again, to how much precision your calculator has. So if you go too far, you're going to start getting ridiculous answers. But the progression of these numbers leads us to believe that they're going to change at later and later and later significant figures. Okay, the 2.71828 isn't going to change no matter how far you go. But that 0 will change, and that 4 is going to change rather quickly. The idea then is that these numbers, these factors, as we compound twice, then 4 times, then 12 times, then 365 times, and so forth, they keep approaching some limiting number. Okay? That's kind of the evidence that we get from this. Now, that doesn't prove that these things actually approach a limit. They might somehow, if you let the number get huge enough, the 2 might change. We might change up to 3 or something, but that doesn't happen. The 2.8 is good. The 0 isn't good if we go further. And there are ways to prove this, and there are ways to calculate this number out to many, many, many significant figures. Okay? Well, the general expression here, if n is the number of times we compound it, is 1 plus 1 over n raised to the n. Okay? Now, as n approaches infinity, as this number gets larger and larger and larger, and their numbers are way, way, way larger than 1,000,000, as n approaches infinity, this number approaches e. Okay? E is the base of the natural exponential function. Okay, our basic exponential function. Arguably, most mathematicians would tell you it's the most important number in mathematics. Turns out that once we know e, we can calculate pi. Okay, based on the value of e. Now there are more direct ways to calculate pi, but pi kind of comes from the number e. Now there are ways to turn that around and say e comes from the number pi, but e is, I think, more general than pi. Okay, now e is approximately 2.718281828, and it looks like it repeats, but it doesn't. Keep repeating. Okay, now what's the significance of e? Now the limiting value, e, of 1 plus 1 over n to the n is pretty close to this, but we see that the limiting value diverges over here. We get 2.71828, just like we had up here, but instead of a 0 here, we have a 1, and then that's followed by an 8. So this actually, if we just did it to this significant figure, it would round off to 2. It's fairly significantly bigger than the 0, but it's way out in this decimal place, so it's not a huge difference. Now this keeps on going. It never stops, but it doesn't keep repeating. It looks like it would repeat. The 1828, 1828 looks like it's going to repeat. It's just a coincidence. It doesn't repeat anywhere. Okay. I mean, well, I say it doesn't repeat anymore. No, it doesn't keep repeating. Actually, this number is so long, has so many digits, that the probability that 1828 repeats twice more at some point in the number is almost 100%. Okay, so what's this mean? This means if we compounded $100 continuously for a year at 100% annual interest, we would end up with, well, 1,000 times this, $2,718.28. And you can see how those numbers relate to the numbers that you calculated, or that were calculated previously, and any numbers that you calculated. Okay, now, if we compound continuously for 2 years, I wonder what we would get. I'm going to leave that as an open question.